Hello everyone, welcome to my channel. Now in this video we are going to discuss problems based on the concept of refraction of light. Now the first question is, a monochromatic light of wavelength 589 nanometer is incident from air to water surface. So it is going from air to water, that is rare to denser medium. What are the wavelength, frequency and speed of reflected light and refracted light? Okay, now wavelength is given. Wavelength is 589 nanometer. Okay, and refractive index of water, it is 1.33, or can be written as 4/3. Okay, now if c is the velocity of light in free space, now c is 3 into 10 power 8 meter per second. Okay, now what are the wavelength, frequency and speed of reflected light and refracted light? Okay, now speed of reflected light, it is not going to change. It is going to remain same, 3 into 10 power 8 meter per second. This is the velocity of light in air. See, the ray is coming from air to water. This is the incident ray, this is the normal, so it will bend towards the normal because it is traveling from rare to denser medium. So a part of it is refracted, this is the refracted ray, and this is the reflected ray. So the incident ray and reflected ray both are in air, and air the velocity is 3 into 10 power 8 meter per second. Okay, so velocity will remain same before and after reflection. Wavelength will also remain same, so wavelength will be same as 589 nanometer. Okay, frequency will remain same, frequency, so these factors will not change in case of reflection. Okay, now let's see what happens in case of refraction. Wavelength, see, refractive index, it is inversely proportional to wavelength. This is the Cauchy law. This is the Cauchy law. So lambda air by lambda water, it will be equal to mu of water divided by mu of air. Now lambda air, it is given to be 589 nanometer. Lambda water is the wavelength of light after refraction in water. Mu of water is 4/3, mu of air is 1. Okay, so lambda wavelength in water, it will be 589 nanometer divided by 4/3. Okay, so this lambda water, this comes to be around 589 divided by 4/3. Now this is around 442.86 nanometer. Okay, I have used calculator, but in exam you will not be allowed to use calculator. Okay, so this is wavelength in water. Now velocity, what will be the velocity in water? Velocity V is equal to C by mu. See, mu is C by V. So this gives V is equal to C by mu. C is velocity of light in air. So V is equal to 3 into 10 power 8 divided by 4/3. So this is around 2.26 into 10 power 8 meter per second. Okay, so wavelength and velocity, it will change. Frequency will not change, frequency will remain same in air as well as in water. There is no change in frequency, but there will be change in wavelength, there will be change in velocity of light. Okay, so in this question the main concept is, in reflection no change in velocity, wavelength and frequency. In refraction change in velocity and wavelength, frequency unchanged. Okay, so I hope this question and the concept is clear to you.